Hey Savvy people, it's Savvy Nick here, and today I plan on continuing with the Python tutorial and learning about Python. I see that I have Snaith back watching. Good to have you on. So last time I learned about lists, mainly that they are mutable and you can create shadow copies of them. There's different ways to append them, and there's also slicing. And we even did the Fibonacci sequence example, if I remember right. So today I plan on continuing using the tutorial here on python.org and going through some of this control flow tools. So yeah, of course, feel free to post in the chat. I'll be keeping an eye out on that. I see that Snaith is posting already, which is great. And I'm going to go ahead and start a new file here. And let's save this right away. And we'll call it lesson 4, I guess we're on, .py. All right, and we'll add in our magic line. I think it's just Python. And now we can take a look at chapter 4. So what we have here, we kind of already learned about the if statement, and there's else if else. So I'm not sure why they're showing this again, but let me just read through to make sure there's nothing surprising here. And I don't think there is. I already learned about this, so I'm not going to go through this part. I'm just going to go ahead and skip over that. We did that, and I struggled with a less than or equal to. So I think I'm comfortable with that. So for loops. All right, so they call them for statements. Python differs a bit from C or Pascal, so it is a little different. C. Python for statement iterates over the items of any sequence, a list or a string, in the order that they appear in the sequence. For example, no pun intended. They're very clever here, aren't they? So we have a list with cat window and this word, and for W in words, so I assume the elements in words, we are going to print the length of W. Okay. So I see what they're doing. So they print, and since they're using the list W and it has 3 items in that list, it's going to go ahead through this for loop 3 times, and it's going to print the length of each of the words. Well, that's really nice that they do this for you in Python. You don't have to specify how many items you want to go through, or I'm sure you can, but the fact that you can just do for some list, that's a great thing. So let's give it a shot. So they want words, and I'm going to give some different words here. How about cat, dog, and rat? Why not? And then we'll do a for loop for some number of words in words. Just name this NUM. For num in words, let's print something out, and that is the number and length, much like they have it over here. Oh, num here. All right, so we should get something similar to what they get. Probably need a colon there. I keep forgetting the colons. That's something I need to get used to, because the colons are important. Can't run without the colons. And here we go. Cat 3, dog 3, rat 3. Yeah, I was trying to do that so I can get some of the same length words going. read the chat there. All right, so for loops, fairly easy so far. And this is immensely helpful how they do it. So code that modifies a collection while iterating over the same collection can be tricky to get right. Instead, it is usually more straightforward to loop over a copy of the collection. So we learned about this last time, so like a shadow copy. Or to create a new collection. So let's take a look here. Strategy, iterate over a copy for user in user.copy, users.copy, .items, if status equals inactive, delete users. Okay. Strategy, create a new collection, active users, for user status in users.items, if status equal active, active users, the user status. Interesting. All right, so these are just a little bit, these are just strategies. They're not really examples. All right, we're just going to move on. So for loop, we understand how to do a for loop. But it didn't really give us an example of how, well, what if we want to use a specific amount of elements to go through? I mean, this goes through all the elements inside of a list. Interesting. Guess I'm going to have to figure that out later. All right, continuing on with the range function. We also learned about range in a previous episode. So, I mean, let me look through here just to make sure that there's not something that I don't remember. If you need to iterate over a sequence of numbers. Okay, so this is exactly what I was just talking about. Yeah, instead of going over an entire list, you can go ahead and type in a range and then go over a specific range in the list. So let's just modify this a little bit here. If I copy this, and it's important to keep indentations correct, we'll go ahead and comment this out. For num in some range, and the range is going to be, ooh, let's try messing this up actually. So words has 1, 2, 3 elements, and let me go to 5 elements. And what if I do that? What happens then? Print object of type int has no length. Gotcha. So let's do 4, 3. Probably just have a problem here. So let me look back at this. So for number num length of, not num. Length of what? Oh, I got some messed up. Maybe my. All right, what am I doing wrong then? Let me see if I can make this work first before I get too far. Okay, 0, 1, 4. So what does it not like? We did that earlier, so we can't do it now. All right, well, let's do it this way. So words, num, boom. Index is out of range. All right, that worked. Try 2. I could try 2. I mean, this works here, but length, well, hold on. I'm not specifying what's going inside the for loop. There is no list anymore. It's become a range. So you're not iterating over an object. Therefore, you can't do that. Okay, that makes sense. That's why the second method worked. Thanks for the suggestion, though. I appreciate that. All right, so again, this is just words. We're telling it what list to iterate over and what number in the list to iterate on. So then we get 0, 1 because we have 2, and 3, we get 0, 1, 2, which is cat, dog, rat. Awesome. Hopefully you can hear me all right. If you're new and stopping by to watch this stream today, make sure to subscribe below and hit that notification bell for future streams. We're just finishing up on this range here. We get it now, for sure. The next part, though. The next part, let's see. So this is a range with a start, an end, and a step. So it's stepping in from 0 to 10 in 3 increments of 3. So 0, 3, 6, 9. I get this. I've done this. Range 5 to 10. That just means go from 5 to 10. So it's really 10 minus 1 or n minus 1 in this. And then if we want, we can also do negative numbers, which that's really nice too. So you can go from negative 10 to negative 100 in increments of 30 here. That's great. Yeah, I like this here. That's nice to have. So, okay, to iterate over the indices of a sequence, you can combine range and length as follows. All right. So Mary had a little lamb for I in range length A. All right, so you get the length of the entire list. So all elements, 1, 2, 3, 4, 5 elements. And the length will return 5. I assume 5. And then you go from some number I in the range of 5. So you can print out the entire list. Okay, well, that's nice too, but it's much easier just to put in this. I mean, shoot. You just pass it in the list, pass the whole object in, and it can iterate over the whole object. I think that's a real nice feature, but this is more of like a C-style iteration. So range, length A, and then we can save that. Oh, not A. What am I doing? We have one called words here. And that should work too. Look at that. It works just fine. So we got 0 cat, 1 dog, 2 rat. Awesome, awesome. All right, moving on. So far, we've learned about using ranges in for loops and using an object directly in a for loop. So in most such cases, however, it is convenient to use enumerate function. Strange thing happens if you just print a range. I thought they told us this wasn't something that we should do. Yeah, so literally just prints out range, again, the function range, and says it's going to go from 0 to 10. In many ways, the object returned by range behaves as if it's a list, but in fact it isn't. Huh. All right. Okay, so you can do some range. Sum of a range of numbers. Let's try that real quick, just to say what we did. So sum range. Oh, Matsu, nice to see you again. Thanks for coming. I'm glad you made it. All right, so back to this. So sum range, I'm just gonna put, I don't know, 10, why not? So 10 plus 9, 8, 7, 6, 5, 4, 3, 2, 1. That's what I would expect, right? Print. Hold on, it's complaining about something. Sum. Oh yeah. Sum. Don't have to define an int. Don't have to define an int. X equals sum. I would hope. Maybe not. Print x. Let's try that out. Okay. Yep. Got that right. Sweet. Yeah, I'm always wanting to go ahead and define what data type it is, you know? I'm always trying to do int, char, whatever. Gotta get past that. All right. So we have a list of, so later we'll see more functions. Lastly, you're curious about how to get a list from range. Here's the solution. Cool. So you can create a list fairly easily by, don't even have to fill in the numbers. Well, this would have been nice a couple times already. So you can just throw in a range. Let's do 10 again and print, well, I'm going to call this list y and print y. So I should get 45 and then a list from 0 to 9. Look at that. Awesome. That's pretty cool. I did go ahead and check out PyCharm. That looks pretty nice. Although I'm really used to using Visual Studio Code, so I'm going to remain on that for a while. And I also, I think it was called Pygame. I checked that out. It looks like you can make little mini games and stuff using Pygame. Some kind of a framework for games in Python. So, moving on. Hopefully you guys can see this all right over here on the right-hand side. I hope everyone can see it because I like being able to read and look at it at the same, or look at the code and read at the same time. But there's no better way. I don't have a bigger screen here, so again, hopefully that works. There we go. We don't need that side list. That's a little better. All right, and I guess we can continue on to 4.4. So the break and continue statements and else clauses on loops. All right, so I think we kind of already did this. While has all the same type of stuff. So continue, you continue on from that point on to the next iteration. Break, you're going to break out of the current for loop or while loop or whatever you got going on as soon as you call it. Else, you will do something else. So here is a perfect example where they have two for loops and an else statement. So I'm glad you think it's awesome there, Snaith. For n in range 2 to 10. So here is the prime number example. Now this seems to be a little bit of a brute force way to find a prime number, but it works. I'm sure it works very well. But you can imagine if you get up to some really large number, you're going to be going through a lot of iterations here in order to go ahead and figure out whether or not that prime number is a prime number. Or not that. Whether a number is a prime number. So let's go ahead and do this, but also break it. So I'm just going to comment this out. One thing I haven't seen is them talk about commenting things out. Does anyone know how to comment more than one line out? Because I could have used that quite a few times by now. But for now, I'm just using hashtags. So we'll do for some number, I'm going to call it num, in a range of 2, and I'll come back here and fill this in. Hopefully I remember. So for x in a range of 2 to some number, num, can't forget my colons, then if n modulus x is, so if n mod x is equal to 0, meaning there's no remainder, we're going to print that n equals x times n divided by x. All right, and this I believe just returns, or what does that do? N double divide sign. That must return, well, we'll try it out here in a second, and then I'll look at it. That must return that must return a remainder. Yeah. All right, so in line with the second for loop, else we're gonna fall out of the we fell out of the for loop because I missed the break. Yeah, so if you find something that is divisible, you will break out of the first loop, and then in the second loop you're going to go ahead and say this number is a prime number. So you found a match, something divisible. All right, and all of these are num because I want to use number for emphasis. All right, so now we get to fill in a number. So let's go to 20. We'll go to 20 instead. And here we go. So let's check out if it gave us the right prime numbers. So you got to remember, a prime number is something that you can't divide into. So as it says here, let's see. So 2 is a prime number. Nothing can divide into it besides itself. 3 is a prime number. 4 is not a prime number. 5 is a prime number. 6 is not. 7 is a prime. So on and so forth. So this seems to work great. But here's the issue I see. So if we use this method, the problem that we're going to run into is you have to keep iterating through and then let's see, for x in a range of 2 to some number, and numbers going between 2 to whatever. So here you would, let's say you got to 20 and you're on 20, increment 20. You would go again of a for loop up to 20 times. That's a lot. And that number keeps growing. So what if we did 200? Would that take a while? No. How about we do 2,000? That took a little longer. You can see I had a little bit of trouble spitting it out there. How about 20,000? There we go. Yeah, see how long that's taken now? Although it's still not bad. But let's try 200,000. Now you're asking a lot. Yeah, it's going to take quite a few minutes here. Or not minutes, but it's going to take, shoot, I mean, it's almost a second a number. So there's actually a different way to solve this. You could create an array, and that array would be filled with whatever number. Well, it'd be up to whatever prime number you're looking for. So let's say we had 200,000. You can make an array of 200,000 elements in it. And then each of the elements you could set to true at the beginning, and then slowly work your way up through each iteration and see if each individual spot in the array, so you'd start with whatever, 2, and you check if there's anything that could divide in the 2, and you'd set it to false if you couldn't, and you'd keep iterating. Oh. Says it's not multi-line comment, but you can use 3. Okay. I'll give that a shot real quick. But yeah, this thing's going on, and you can see how long it's taken us now to find these prime numbers. I mean, this is 200,000. You want to find prime numbers up to 200,000. That's a lot. So I think a more efficient way would be creating an array, filling it all with true, and then testing each individual case. And if you come up against a case that's already false, you skip over that case and you just move on. I think that would save you some time. Thanks for posting that, Matsu. Let me, I'll give that a shot. So I'm going to just Control C out of here, hopefully. Nope. Interrupt. Okay. It just took a while to get the interrupt. And let me see if I can multi-line comment. Oh, look at that. I mean, it changed colors. That's always a good thing. Let's see if that works. Oh, it looks like it worked. Sweet. Thank you. I appreciate that. That is going to save me some time. All right. So we just completed their prime number example. Yeah, it is a really big number, isn't it? 200,000. Could you imagine doing 2 million? I think I'll spend some time. I'll spend some time maybe in a little bit and just make a second type of function that can find prime numbers or tell you whether or not a number is prime. And then we can compare the speeds of both of them. Let's say to do 200,000 iterations, and we'll see which one completes quicker. I'd be interested in seeing that. And if you're still with me here and haven't hit that like button, please do so. It really does help me out. I think we'll go ahead and just continue on. I got some more time here, so might as well. Maybe we can get through this whole chapter. I don't know. It does seem pretty big. We're not that far. All right. So let's see. Okay, so here they're finding an even number. Much of a similar way, they're just using continue with this one. So in this example, they're doing for some number in a range from 2 to 10. If 2 is 2 mod, if a number mod 2 is equal to 0, meaning there's no remainder, it's an even number. Otherwise, it's not an even number and you don't continue. So this if statement, if it's true, you're going to continue and skip over this print statement. Otherwise, you are going to go inside the if statement. All right. That's easy enough to follow along. I don't think I'm going to do that one. Pass statements. Now, this is something new I don't know about. So what is a pass statement? Pass statement does nothing. Well, that's a fancy statement. That's like typing nothing. Well, true. Class, empty class. Commonly used for creating minimal classes. Another place pass. Okay. This last one makes a little more sense. So you can use a pass as just a placeholder and to remind you to implement something it says. That's kind of cool. I mean, it's a unique statement. It'd be much like just making a void function and doing nothing with it. But this is giving us a bit of a glimpse to how they create a class and how they, I assume, define a function. That we have not learned yet, but look at the next section is defining functions. Now it's getting exciting. Create a function. Could this be our first function? All right. Let's see here. We can create a function that writes a Fibonacci series to an arbitrary boundary. Ooh, we already did this last time, so maybe we could just copy and paste. Lesson 3. Wasn't this a Fibonacci sequence? Sure, it looks like it. Let's keep it. Paste it over here, and let's play with it. So we have a definition, and I guess you define, this is how you define a function. And you can pass in, well, we want to pass in, no, we don't. We want to pass in a number, n. Just going to use num here. So we're going to define a function called fib for Fibonacci. I'm going to pass a number, num, and it looks like it's important to keep the indentation correct. So we'll tab over. And now we can call the function, but the function is called afterwards. So is there anything in Python where you can define a prototype, that way you can write your functions at the the end of the program, and you can call them from somewhere up top. I'll have to learn about that, but okay, let's give this a shot though. So I am forgetting something. Colon. That thing is always tricking me, but fib, and we did 1,000, but these people are doing 2,000, so let's give 2,000 a shot. Why not? Wow, that worked. Cool. Our first function. And it seems pretty simple to define them. So the keyword def introduces a function definition. Wonder what happens. I'm just gonna give this a shot. Will it find the function? Not defined. Go figure. Yeah, of course it's not defined. But I wonder if there's such things as prototypes in here. Fib. Oh, f equals. Simple table, the value. Fib. Fib function fib at. So what? Can we do that? So what if I did print fib? Will that give me the memory location of fib? Ooh, look at that. Function fib at. Boom, boom, boom. Well, that's neat. All you have to do is pass in a function to print and you know exactly where it's at. F equal fib, f of 100, and you can still use it as a function. So you can, now does this create a shadow copy or a full copy? How does that work? Okay, coming from other languages, you might object that fib's not a function, but a procedure since it doesn't return a value. Okay, sure. In fact, even functions without a return do return a value, albeit a rather boring one. This value is called none. All right, so it's like void, but it's built in. So instead of saying void some function, you just say, and I'm comparing this to C, instead of saying void some function, you don't have to say anything, but none is returned regardless. You know what? We've gotten pretty far. I mean, shoot, we're on the 4th chapter already. I don't know how many chapters even exist. But let's see. Fib of 0. Fib 0. sure. We already did this last time. Yeah, we did exactly that. So I'm not going to do it again. But there is a return. Okay, well, I need to learn about returning things, so I would want to try that out. So as you can see here, we've already done this, the fib sequence. And let's just do it again. And thanks to Metsu, I get to use my multi-line comment out, which is great. Makes things much quicker. Thanks again. And now we have, let's make sure we can run this. Oh, don't want to comment this out. Let's make sure we can run this. All right, great. And we're just going to make some modifications here. We want this all in a function right here. Don't need the print yet. Well, we'll need a print later, so I'll keep the print. And we're going to define a fib function and pass in a number. And inside this Fibonacci function, fib function, we want to return a result. And that result is going to be, well, fib. So I'm just going to return fib. And that should return a whole list back to whatever makes the function call. So if I do, let's see. Okay, sure. This will be I assume this is a new list is going to be equal to fib. How about we do new fib list? The new fib list is going to be fib, let's just do to 1,000, save that, and I forgot to print it. We'll print the list. And in order to print a list, it's very simple. We just type in new fib list, the list name, and it prints out the entire list. Awesome. I might have got disconnected there for just a moment. Sorry about that. Okay. So now we understand how to create functions, how to return something from functions. That's fantastic. That helps a lot. We also understand how to use for loops, ranges in for loops. Let's see if I want to go further here. What are we thinking? Should we go further? Or should we call it default arguments? More on defining functions. Okay, so variable number of arguments. So varying arguments. Now this, I mean, what's the point of this? Is this a default? Okay, that's interesting. This creates a function called with fewer arguments than it is to allow, for example. Okay, so I assume, okay. If they, now let's just give it a shot. Comment this out. So definition of ask, okay. We're gonna have a prompt, some amount of retries, which let's just say 10 retries because we're very nice. A reminder, try again. Just trying to keep it a little shorter here. Don't forget my colon. Look at that, didn't forget it that time. While something's true is case sensitive, we'll do okay, the input prompt. Otherwise, if okay in, let's see, if they give us y, ye, or yes, then that's interesting. Return true. If okay in n, no, I'm not going to do the nope or nope. Return false. Retries, stops, I assume retries. Oh, they get one less try, or one more try. Make sure this is in line with the while. And moving on, if retries is less than 0, then raise, that's something new too, value error, invalid response. Print the reminder. Okay. Nothing. Yeah, because it's a function. So ask okay. Make a call to that. It's missing. Of course, a prompt. Yeah. Here we go. So enter something. Try again. Try again. Try again. Try again. So try again until I'm sure 10 times in. So keep messing with that. And there you go. Raise an error, value error, invalid response. And it tells us invalid response. That's interesting. But what if I wanted to say, no, I don't want to do it like 10 times. I want to do it 3. Is that possible? Oh, look at that. Okay, so enter. Okay, that worked. Yeah, so this is what they do right here as well. So these are just kind of initialized here. Whether or not, you know, if the user supplies the argument, great, it's going to go ahead and use the user supplied argument. Otherwise, it's going to have some type of a default. So the default for the retries is 10. The default for reminders, try again. Prompt doesn't have one, so if the user doesn't supply a prompt, the function will fail. All right, cool. This example also introduces the in keyword, does it? Test certain value. Yes, it does. Yeah, I didn't realize you could do this. Whoa. Yeah, what happens here? I is equal to 5, I is equal to 6, and then the function's called. What's I? Do you think it's 5 or 6? Let's give it a shot. Let me get rid of this. I understand what's happening here now. Very good. I equal to 5. Define a function with an argument equal to, say, I. Pass in the I as an argument. Print that argument. And we say we're overwriting 5 to 6 now. And what happens to that function? Is it 5 or 6? It's 5. Interesting. Default value is evaluated only once. Okay. Well, that's good to know. Define A, append A, return L. 1, 2, 3. It should do 1, 1, 2, 1, 2, 3. Yeah, that makes complete sense. We learned about append last time, so you can append to a list, and it's appending a number to the list, and you're passing in 1, 2, 3. So you would expect that the list grows every single time because you're just appending to the list and you're returning the list once more. But that is interesting. I wonder if you didn't return the list, then surely it wouldn't. You know what? Let's give this a shot. Just seeing what else we have left. Yeah, I think we'll just give this a shot here. And then I think I'm going to call it. I think we've been going long enough here. I don't know if you guys agree or not, but I don't want to bore everyone either. So get rid of this. Looks like I can maybe even use just 3 apostrophes. Oh, maybe more. Ah, cool. Apostrophe. Matsuo, if you're still there, you can use 3 apostrophes apparently too. Didn't know that, but I just gave it a shot. Looks like it worked. So define a function A with a list. They do capital L, so I'll just keep it the same. And it's initialized by nothing. L.append, we're appending something to the list. We're appending A, which is an argument that gets passed in, and then we're returning the list. So if we do print f of 1, I'll do this 3 times. 2, 3. Let's see what happens, just like they have it. But what if I don't return anything? What happens then? None. Okay. Sure, because it doesn't return anything, but we're calling a function, and then we're printing out what it returns, and since it didn't return anything, it just spit out none. Very good. But look at this little tricky thing. If we define a list as none, with a capital N, and say if L is none, L is equal to, so now we're just changing the scope of stuff, it looks like. So now we say if L is none, which it will be initially, right? Otherwise, unless you specify it, then L is equal to, well, a new list. A cleared list, I should say. It's a cleared list. It's not a new list, a cleared list. Or is it? I thought this was a cleared list. Maybe a new list. L.append A, return L. What happens here? Nothing happens because I forgot the semicolon. Okay, so this makes sense. So initially we pass in nothing for L, none, I assume. And then if L is none, then we initialize L as nothing. Then we append something to L, and we return L. The next time through, it's going to do the same thing. But what if we said, let's see if we can trick it. Instead of L equal to none, we do L equal to, does that do anything? Nah, you can't do that. What if we do, that's, no, you can, L, what if we pass in, what if we make it here? So another list to pass in a list. Ah, that did something. Oops. No, I'm getting carried away now. Just messing with stuff. Yeah, nothing. Oh, that's stupid of me because I'm not. Print. Putting in the wrong spot. That's not what I expected. There we go. Look at that. What if we did, could you do, no, I did it right the first time, but now it's just something I want to try. Cool. All right, so that works too. So none, you can default something as none, and if someone wants to pass something in and say, hey, I want that list, they can get a list out of it instead. How great. Yeah, Python really is powerful. It's got quite a few little tricks up its sleeve, making things very easy to manipulate. I do that, and I really do enjoy that about Python so far. How forgiving it is amazing. Well, I think this is where I call it quits for this stream. I hope you enjoyed it, and I also hope you enjoyed going through this tutorial here using Python and the python.org guide here. It's been pretty good so far. We've learned quite a few things, and I mean, just this time we learned about, well, functions, how to define them, how to return values, how to default certain arguments, as well as this right here, this in operator. That's a special way. We did the we already had done the Fibonacci sequence, but we did the prime numbers, learned how to define functions, already said that. We used the pass statement, which just is kind of a placeholder, it seems like. We have this in range. We already used ranges before, but we used it for our prime numbers. And learned about break and continue in for loops, as well as else clauses. A lot of stuff today. So I'm happy where I'm at. Yeah, exactly. That's exactly right. Matsu, it's impressive. You can do a lot by writing a little. I mean, that Fibonacci sequence, without having to do, some kind of I imagine in C, C++, you have to do some kind of recursive function, or at least you could take advantage of a recursive function in order to come out with some kind of Fibonacci sequence. That might be like the way to write the least amount of code, but in here, I mean, shoot, quite a bit different. All right, well, this is where I'm going to call it. So thanks for watching, everyone. I'll definitely catch you in the next one. Hopefully sooner than later, maybe in a couple days here when I get a little bit of time. And if you are new and stopping by today, make sure to subscribe for the next one so you can go ahead and follow along. I'll try to go ahead and post a that I'm going to do a live stream hours in advance. I've been bad about that at the beginning of everything, but today I think I made at least 6 hours notice. So if you are subscribed, you will get a message hopefully, and you'll be able to see that I will be doing one. And make sure to like it as well. The more people that watch it, the more we can get involved. And I like chatting with you guys, so always feel free to chat. And Snaith, thanks for coming and chatting with me. Matsu, you as well. I really appreciate you guys coming, and catch you in the next one, all right?